With the introduction of active steering in the E60, BMW launched a revolution in steering systems in 2003. A new level of freedom was attained through the use of active steering, and BMW was the first car manufacturer worldwide to implement this system. A steering angle superimposed in the active steering lowers the steering effort of the driver and combines the possibilities of steer-by-wire steering with authentic steering feedback. This system can also have a stabilizing effect on the driving dynamics by applying corrective steering in certain driving situations. To expand this lead in the field of dynamic driving, the familiar active steering is now supplemented by active rear wheel steering and forms a new system in the new BMW 7 Series. The active intervention in the steering on the rear axle is the logical extension of the active steering. Both systems are now combined and referred to as integral active steering. The steering angle of the rear wheels can be increased or decreased by up to 3 degrees in both directions by means of an electromechanical actuator. This consists essentially of an electric motor and a spindle drive that moves the rear track rods. After a system failure, the spindle drive locks the rear steering and the vehicle handles in a manner identical to one without rear wheel steering. Part of the rear wheel steering is a separate actuator control unit, which controls and monitors the actuator. Until recently, control systems were largely designed independently of each other. In the F01, these systems are linked through the integrated chassis management. In the ICM system, a central control unit replaces the previous dynamic driving sensors and forms a central dynamic driving controller. All dynamic driving functions are calculated in this ICM control unit. The ICM system thus allows a new quality of dynamic driving control. The variable steering gear ratio of the active steering reduces the steering effort to around 2 turns from lock to lock. Coupled with the variable steering gear ratio, the steering angle of the rear wheels in the opposite direction to the front wheels ensures more maneuverability. When a vehicle is steered, the vehicle turns during cornering around the so-called instantaneous pole, labeled M. With conventional vehicles, this is situated in the area of the rear axle. If active steering is installed in the vehicle, less steering effort is required, making the vehicle more agile. Through the active steering intervention on the rear wheels, the steering angle of the rear wheels is set in a contrary direction up to a speed of around 60 kilometers per hour. The result? The center of rotation moves near to the center of the vehicle, given the same steering effort. In terms of maneuverability and dynamism, this corresponds to a vehicle with shorter wheelbase. With increasing driving speed, the steering angle support of the active steering is withdrawn. The steering gear ratio becomes more indirect. At the same time, the steering strategy on the rear wheel steering changes. At lower speeds, the rear wheels turn contrary to the front wheels. At high speeds, both front and rear wheels turn in the same direction. The instantaneous pull moves further back. This corresponds to a vehicle with longer wheelbase, resulting in an increase in directional stability. The curve radius becomes bigger as a result. Through the coupling with the active steering, an additional angle on the wheels is added to the front axle. The curve radius and the required steering lock remains at the usual level. Altogether, the coordination of the steering interventions on the front and rear axle allow the driver to carry out lane changes and steering maneuvers much more safely, without any loss of vehicle agility or handling. The coupling of the active steering with the recently developed rear wheel steering brings advantages for the customer in all speed ranges. All vehicles tend to produce noticeable yaw reactions during quick lane changing and can oversteer. If the ICM dynamic driving controller recognizes a deviation between driver intention and vehicle reaction, it initiates coordinated steering interventions on the front and rear axle. The quick stabilizing intervention is almost imperceptible to the driver. Delayed DSC brake interventions can be largely avoided. The result, the vehicle is more stable and better balanced. If a driver enters a bend too quickly while driving at speed along a country road, he can be surprised by sudden understeering and even cross into the opposite lane. The principle of active steering only reacts to a vehicle that is oversteering. The integral active steering with the active rear axle steering can also intervene correctively in situations where understeering occurs, thereby contributing to an additional increase in active safety. Quick braking maneuvers on roads that are slippery on one side cause the vehicle to rotate in the direction of the part of the road that offers more grip. During an emergency braking operation, the driver of a conventional vehicle has to intervene to correct this. In the case of these braking situations where the tires have different amounts of grip on either side of the vehicle, the dynamic drive controller sets a stabilizing yaw moment via counter-steering interventions on the front and rear axle. This compensates the slippage of the vehicle through the one-sided braking forces. Maximum braking forces can in this way be applied to achieve a short braking distance. The development of integral active steering is the logical further development of active steering systems. The functions of the systems complement each other perfectly to provide a new dimension in driving experience. Active steering systems are, of course, systems which cannot be switched on and off by the customer. In the case of integral active steering, there is exception. When snow chains are mounted on the rear axle, no active steering intervention is possible on the rear wheels. The automatic snow chain detection supports the driver and shows the detected state in the control display. This does not avoid the need for a manual setting. If snow chains are used, the driver must set the system for this via the Snow Chains menu settings in iDrive. When snow chains are used, the rear axle steering is deactivated. If the driver exceeds the maximum admissible speed with snow chains, 50 km per hour, the rear axle steering is reactivated, despite the fact that snow chain mode is set. By combining driver-independent active steering interventions on front and rear axle, the conflict of interest between agility and stability can be resolved to an extent never previously achieved.